I welcome you all once again to another video, and today I'm going to be talking about definite integrals. So what is a definite integral? A definite integral is just an integral with with specific limit, that is the lower limit and the upper limit. So today I'm just going to look at another example. We are going to work on an example, and we will know what we are talking about when we're talking about definite integral. So here I have a question. The question says that find the area of the figure bounded by the graphs of the following functions. Okay, so these are the functions. So let me start by writing the functions. So the first function is y is equal to sine x. The second function is y is equal to cos x, and we have this equation also, x equal to 0 and x equal to 3 pi over 2. So these are the functions that we have. So we are told to calculate the area of the figure that is bounded by these functions, and for us to find this area, we need to draw the graphs, and we need to see this area which is bounded by these functions. So it's important right now for us to draw this graph. So for us to draw a graph, we're going to plot a table. So I'm going to put x on top and y below. So what I will do is I will take the values of x from 0 maybe to 270 degrees, and let's make my interval 30 degrees. Okay, so why am I talking about degrees? This is a function, this is a trigonometric function, and when we talk of trigonometry, we are talking of angles. Okay, so I take, for say, x 0, 30, 60, 90, 120, 150, 180, 210, 240, and 270. And for this is a table, and for me to calculate the values of y given these values of x, I need to use the function. So how do I find the value of y? I need to use the function and substitute in where there's x with the degree that represent x. So first I'm going to find the sine of 0. So I'll take my calculator, and since I'm using degrees, I should make sure that my calculator is in degrees. And as I look at it, my calculator is in radians, so I need to change the setup. So I'll change the setup, and here the degrees, I need to press 3. You know, my calculator is in degrees, so it's important if you're using angles and trigonometry and you're using calculator, make sure your calculator is in degrees for you to use angles and degrees. It might be in radians, then remember to use all degrees in radians. So I'll have sine 0, and the answer is 0. And I'll have sine 30, and the answer is 0.5. And the same way I'll have sine 60, and I have a decimal, this one 0 point, and I'll round it 2 decimal places, and I'll have 0.87, and I'll have sine 90, that would be 1, and I'll have sine 120, and that will be another decimal, which is 0.87, and I will have sine 150, and this is also 0.5, and sine 180, this gives me 0. Then again I'll have sine 210, this gives me a negative 0.5, and I will have sine 240, this gives me a negative 0.87, and I will have sine 270, and I will have a negative 1. Okay, so this is the table of values for the function y is equal to sine x. So I also need to create a table of values of y is equal to cos x. So in the same way, y is equal to cos x. So I'll take the values of x from 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, and I'll take the values of y. So how do I find the values of y? I'll find the values of y by substituting in the function where there's x. I put the value of x in degrees and choose my calculator to calculate all the values of y. So let's start. Cos 0 is equal to 1, and cos 30 is equal to 0.87. I've rounded it to 2 decimal places. It's just a long decimal number, so I've just rounded to 2 decimal places. And let's have cos of 60. Cos 60, it's also 0.5, and cos 90, it's 0, and cos 120, this gives me a negative 0.5, and cos of 150, this gives me negative 0.87. I've rounded it again to 2 decimal places. Then I'll have cos of 180, this gives me a negative 1, and then I will have cos of 210 degrees, that's a negative 0.87. I've rounded it to 2 decimal places, and I will have cos of 240, that would be equal to negative 0.5, and finally I'll have cos of 270, and that will be equal to 0. So now I have my table of these 2 functions, and it's now easy for me to sketch the graphs. And after I finish sketching the graphs, I'll be able to see the figure that is bounded by these graphs, and after that I'll be able to calculate the area given by this figure. Okay, so now let's draw the graphs given by these functions. So I'm going to draw the axis. So here's my y-axis, and here's my x-axis. Here's my x. This is my x, this is my y-axis. So I need to find the scale that I might need to use on the x-axis. So how many values of x do I have? I have them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 values. So let me see if I put each value after two boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's reasonable. So let me just mark my points on the axis where I'm going to put the values. Your axis should be big enough so that it will allow you to see how these graphs move. So let me see how I'm going to need to do my scale on the y-axis. So on the y-axis I have a minimum value of -1 and a maximum value of +1. So let's see if I'm after two boxes I count as it's 0.25. I'll have 1, 2, 3, 4. It's reasonable too. So I'm going to use two boxes to be equal to 0.25. So I have positive 0.25. Here we have 0.50, and here we have 0.75, and finally I have 1, and below I'll have negative 0.25, negative 0.50, negative 0.75, and finally I will have negative 1.00. And here this is my O, that's and with the intercepts I'll have 0, and here I'll have 30, 60, 90, 120, 150, 180, 210, 240, and 270. Yeah, something like this. And now I need to put my points on the graph, and after this I will see what are the figures that are bound by this graph, by these graphs, and I'll be able to see how I can calculate the area of these figures. So beginning with the function y is equals to sine x, I will have, when x equal to 0, I have y equal to 0. And when x equal to 30, I have y equal to 0.5. this is the point 0.5, not this one, this is the point. When x equal to 60, I have y equal to 0.87, which is a little bit above this line, which is a little bit here, and y equal to x equal to 90, I have y equal to 1. So I have a point in this, and x equal to 120, y equal to 0.87. So this graph is going to be symmetrical, and x equal to 150, y equal to positive 0.5, x equal to 180, this gives me 0, this is a point, and x equal to 210, I have a negative 0.5, x equal to 240, I have negative 0.87, which is a little bit behind, above this line. And finally, x equal to 270, I have a negative 1. So I need to draw a curve joining these points, and I will have my graph. So drawing this curve, it will be something like this, then it goes like this, then it goes like this, then it comes like this. So this is the curve that I have produced. This is the function y equal to sine x. It's good to label the function so that we will be able to see each graph and its function. So in the same way, we need to plot the point for y equal to cosinus x, and we get these values from the tables above. And now plotting the graph, x equal to 0 from our table, y equal to positive 1, we have a point, x equal to 30, and we have a positive 0.87 here, and x equal to 60, we have 0.5, x equal to 90, we have 0, x equal to 120, we have negative 0.5, x equal to 150, we have a negative 0.87, which is just a little bit here, and x equal to 180, we have a negative 1, we have a negative 1, so this is the point, negative 1, and that's the value of y, and the value of x at this point, it's 180. And x equal to 210 degrees, from the table we have a negative 0.87, which is this point, a bit here, and x equal to 240, we have a negative 0.5, which is this point, and finally x equal to 270, we have a 0. So now we need to join these points and see how the graph goes. So here. This is how it will look. We are joining the points just like this, just like this. And I will label my function, this graph, with the function y is equal to cos x. Okay, so now there's another information that I was given about these functions. I have the line x equal to 0, and the line x equal to 0, it lies in the y-axis. Okay, that's where my line x equal to 0 is just a vertical line which passes through 0. Okay, that means x equal to 0. So I might label this axis x equal to 0. Then I have a line which is x equal to 3 pi over 2. So pi is in radians, it represents 180 degrees, and its value, it's about 3.14 something. Okay, it's just a value in radians. So how do we convert a number, an angle which is given in p to degrees? Okay, we just need to substitute pi with 180 degrees. So solving that a substitution, we have x equal to 270 degrees. So x equal to 270 degrees in our graph is just a vertical line which passes through x equal to 270 degrees. So I'll plot it so that you see it. Okay, x equal to 3 pi divided by 2. Now I've finished plotting my graphs, and the next thing that I need to do is to shade the figures which are bounded by these graphs. So I can actually see that as this portion is bounded by these same graphs, and I have this portion is bounded by the same graphs, and I have this portion these are the portions which are bounded by these graphs. So how do I calculate the area? So generally we need to understand, if we are integrating a function and if we are given specific limits, we are generally finding the area under this graph. Okay, so that's integrating. It's a process. When you integrate a function, you're just finding area that is under this graph. So we need to find points of intersection for us to find the limits. Okay, so here we have a point of intersection, and we need to know the value of x, where the graph of sine x and the graph of cos x intersects. Okay, so we're going to solve an equation when the graph of sine x intersects with the graph of cos x is just the value of x at that point. We just find it after we equate these two functions. That is, if we're going to solve the equation sine x is equal to cos x. So now let's begin to solve this equation. So the equation that we're going to solve is sine x is equal to cos x. Okay, it's a trigonometric equation. So how do we solve such equation? Here we can simply divide both sides by cosinus x and cosinus x, and at the left side you are left with sine x divided by cosine x is equal to tan x is equal to 1. Okay, so x is equal to arctan of 1. And this, I'll just take my calculator and make sure that it's in degrees, and I find arctan of 1, and that's 45 degrees. That's 45 degrees, which is x, and this is the same as pi divided by 4. Okay, so I found the first coordinates of the intersection. So by this now being a trigonometric equation, I just want to tell you about trigonometric equations. So since we have a trigonometric equation, we will always have a multiple of solutions. Why? Because as the values of x increases, they increase up to 360, and if you get to 360 you are back to 0. So this is how we solve for multiple angles. Okay, we'll draw this, and in this first quarter we have O. Here we have sine x being positive, here we've got tan x being positive, here we've got cos x being positive. So here I found my x to be 45 degrees, so in the same time I have another 45 degrees in this region of, because this is the region of tangent, and I have been solving the equation of tangent. So I have 45 degrees over here, I have 45 degrees over here. So for me to know this angle, I'll measure it from this in an anti-clockwise direction and have this angle, and that angle is going to be 180 plus 45 degrees. That gives me 225 degrees. So another value of x is also equal to 225 degrees. Okay, so coming back to my equation, to my graphs, this is the first point of intersection. This is equal to 45 degrees, and this is the second point of intersection, which is equal to 225 degrees. Okay, so now I can solve my integral, and remember guys, 45 degrees is just equal to pi over 4. Okay, and 225 degrees is 5 pi divided by here divided by 4. Okay, this is another point of intersection, but it's in radian. Okay, so But let's take another look to our graph. Okay, this graph, we can easily see that it's symmetrical. So to find the whole area, we can find the area of the half part, and after finding that area, we can just multiply it by 2. Okay, as simple as that. So let me label these areas. Let me call this 1, and let me call this 2, and let me call this 3. Okay, and I might want to call this this. I might want to call this 2.1, and this maybe I might want to call it 2.2, since the other one is on top, the other one is under. Okay, so here is how we integrate. This is how we integrate. I'll write my examples here. So the area under the area of 1. Okay, so let's see, S1 representing area is equal to the integral from 0 up to pi divided by 4. This is 45 degrees. This is up to this point, and here I have the graph of cos x being over the graph of sin x. So I will have the integral of cos x minus sin x. Why am I separating my sin x? I need to remove the area under sin x from the area under cos x, because the area under cos x, it covers up to the x's, but the x's now, up to the x's, I don't need all the part, I just need the part which is above the graph of sin x. So what it means, I'll need to subtract this area given by the graph of sin x from the area given by the graph of cos x. Okay, so in that way I will find the graph the area given by these two graphs, the area between these two graphs. Okay, and my vertical line, which is x equal to 0. Okay, so now let's just solve this integral. So my integral is S1, which is given by the integral of from 0 up to pi divided by 4 cos x minus sin x, or I have to put dx. Okay, and here is what I'm going to have. The integral of cos x is equal to sin x, and the integral of, it's just a negative cos x, so plus this negative, I'll get a positive cos x, and I'll have my limits. And S1 is equal to, I'll just put the upper limits and the lower limits, I'll substitute. So this is how we substitute. The upper limit, we put it first, and we have sin p divided by 4 plus cos p pi divided by 4. We put all this in brackets minus cos of minus cos of 0 plus sine of 0. They separate the brackets, and this gives me a value, and this value, in this case I might use a calculator. I might need my calculator, and I will have to punch sine 45. It's being equal to, okay, it's equal to 0.71. This is rounded to 2 decimal places, and cos 45 also is something like 0.71 plus 0.71. This is 2 decimal places. Okay, and I will have to calculate cos 0. That gives me 1, and sine 0, that gives me 0. So I'll have something like 1.42 minus 1, and this gives me 0.42, and this is my S1. And S1, let's take a look again. This is S1, the surface area of our first figure, which is 1, but it is also equal to 3 by symmetry. So S3 is equal to 0.42. Again, we do not need to solve it, it would be a repetition. Okay, so now let's calculate the area given by this one, which is S2.1. So for us to calculate the area, which is S2, we need to see that we need to define our limits. Okay, for us to calculate area S2.1, we need to define our limits. So our limits, we are going to define, we are going to start from where we left these graphs at the point where x is equal to 45 degrees. Okay, so from this point, this will give us a lower limit. Going further, it ends where x is equal to 180 degrees. Okay, so now the function which is above, it's sine x. The function which is lower, it's cos x. So we are going to subtract the function which is low. Okay, so here is how our integral will look like. Okay, our integral will look like this. S2.1 is given by integral from pi divided by 4. Pi divided by 4 is the same as 45 degrees up to pi. The integral of sine x minus cos x or dx. Okay, so we need to solve this definite integral. So here is how we are going to solve it. We have S2.1 is equal to the integral from point P divided by 4 up to point P, sine x minus cos x or dx. Okay, so this would give us the integral of sine x. This would give us a negative cos x and the integral of cos x. This will give us a positive sine x, but just because we have a negative in the expression, it remains negative. Okay, so we put our limits from pi divided by 4 up to pi. Okay, so this is how we're going to solve it. Put the upper limit first in our expression, cos x, that means it's cos p. Okay, cos p minus sine p, going into brackets, minus, we now put the lower limit, negative cos pi divided by 4 minus sine pi divided by 4. Okay, let's solve this. I will need my calculator, and I will have cos 180 is equal to -1, and sine 180 being equal to 0 minus cos p divided by 4. This will give me negative 0.71. This is rounded to 2 decimal places. And this also is give me negative 0.71. This is also rounded up to 2 decimal places, and solving it, it will give me a -1 minus, it will give me negative 1.42, and here it will give me -1 plus 1.42, and here it will give me a positive 0.42. Okay, this is my S.21, and S.21 by symmetry is equal to S.22, which is equal to 0.42. So generally we have found all the area bounded by these graphs. So if we just going to need to find the total area bound by these graphs and these lines, we're just going to add, and this would give us S1 plus S.21 plus S.22 plus S3, which is equal to 0.42 plus 0.42 plus 0.42 plus 0.42, and this would give us, now I'm going to use my calculator again, this is the same as 0.42 multiplied by 4. Okay, multiplied by 4, and this gives me 1.68. Let's call this ST, which is S total, and with this we have come to the ends, and we have found our total surface. Okay, if you watch until the end, it means you like mathematics and you're interested in learning mathematics. So this is the right place. I'm going to bring all topics that are required for you to know in engineering. If you're interested to become an engineer, at least you know what it takes, you know what you need to be acquainted with, you know what you face. And it's not that these things are difficult, these things are not difficult at all, but you just need to do them. And here I will do it methodically, and you guys, I promise, even if you're not interested in engineering, even if you don't want to become an engineer, but you will know what's happening in the engineering world, okay? And if you know anyone who is interested in engineering, just bring him to this place and inform him. It's not mathematics. We have a lot of subjects that I'm going to bring here. Lots of things that I'm going to bring, okay? So stay tuned, guys, and thank you for watching. Thank you for watching up to the end. Thank you for watching. Stay tuned.